Ladies and gentlemen, if you can just take a moment to please silence your mobile devices. Also, just a note that we will have an overflow for this session upstairs on the 5th floor. Thank you. Ladies and gentlemen, please take your seats. The program will begin momentarily. Thank you. Ladies and gentlemen, there are some empty seats in the middle of the rows. If you could please make your way through and fill in those empty seats. Thank you. Ladies and gentlemen, please welcome to the stage Jay Parikh, Global Head of Engineering, Facebook.
All right, good morning. It's great to be here. Welcome to our first big at scale 2014. So I'm really excited to be here for actually 3 reasons. First reason is that this is the first time we've actually been able to assemble all of the folks that have attended some of the other conferences in one event like this today. And it's actually pretty incredible to see how many friends, colleagues, and actually in general just really smart people who care about scale topics like we do to be able to come and spend the day talking about these technical challenges that we have, the stuff that we're building, and sharing experiences with each other. This sure beats the shit out of any other Monday that I normally do too as well. So it's awesome to be here. Second reason that it's really good to be here is actually we raised a bunch of money for code.org today thanks to your registration fees. So as you all know, and we all want to support, we want to increase the number and also the diversity of students that have access to computer science by broadening this out to more and more schools around the world. So thank you for your contributions today, and I know it'll go a long way. So. All right, so as I mentioned before, this is the first time we've done one big event. We've done several other ones that you can see here up on the screen, an analytics at scale, a data at scale, mobile, security, and sustainability. We've been doing these events in a smaller forum for about a year now, and we have plans to do a lot more over the course of the next several months as well. Now, I think it's really good that we're able to bring this community together specifically because we're trying to focus on the challenges that we all face at doing at-scale engineering. And so being able to kind of bring everything together, to bring multiple tracks together today across data, web, and mobile, instead of just having a single track, hopefully will allow you to be able to kind of dive into some topics that may be unfamiliar to you, and also kind of meet other people and be able to share experiences and learn a lot, ask a lot of questions in these areas that you want to learn a lot. The entire day is technical stuff, right? So hopefully you guys have looked at the agenda. There's no vendors here promoting stuff, selling stuff, advertising stuff. We just want to kind of geek out all day and talk about technical stuff, and hopefully this will be able to impact and help you when you get back to work tomorrow. So now, we have quite a lineup of talks today, and these are the companies that are here this afternoon presenting, and also on the panel that follows my talk. But before we get into the panel and the talks, I wanted to spend a little bit of time talking about why I think and why we think it's important for us to build this community around scale and around being open and working together. So there's three things that I think kind of bring us together. First is challenges, two is the approach, and three is open. And I'm going to talk about each one of these for a few minutes. So we all face pretty unique challenges. We have unprecedented scaling challenges. Many of us have applications or services that we have to build that will scale to millions, possibly billions of people. We work on things like data infrastructure that has to scale to petabytes, tens of petabytes, hundreds of petabytes, maybe even exabytes of data being processed and stored in a data infrastructure. We have to actually deal with supporting applications, mobile applications, across thousands of different devices across our user base or customer base. And finally, we all work on taking JavaScript and making it defy the law of physics to do things that we wanted to do. Now, one of the stories that I want to talk a little bit about here, just real quick, to kind of give you a perspective on the mobile world and what it's doing. As most of you know, about 2 years ago, Facebook ended up having to do a pretty radical shift in terms of building our products mobile first. We had to retool all of our build and release tools. We had to retrain the engineering team. We had to focus on all of our our design and product side, with mobile being the first thing that everybody works on. And one of the things that we learned recently, I guess in the last year or so, is that we had a lot of work to do to improve the quality of our applications. Just designing and building mobile applications for the high-end smartphone and on an LTE network doesn't actually cut it. So a bunch of engineers and product managers actually flew to Africa and a few other places around the world and actually did a bunch of tests. What we found was actually pretty striking. Our apps basically sucked, right? We had the team land, they bought a bunch of devices, they found that our apps crashed often, they used too much data, they were slow, and they also were robbing basically, or basically consuming all the battery on these devices. In fact, one story goes that, or one of our engineers actually had a data plan, and just by trying to download the update to a Facebook application, he ran out of his data plan in 40 minutes. So he basically was trying to download the app for 40 minutes, and then he ran out of data because he couldn't download. He didn't have enough data to download the app. So this was pretty frustrating for us, and the team came back and spent a bunch of time over the course of the 6 months following the trip to really dig into and improve our applications so that they could work across a wider range of devices. Now, this is an ongoing problem. This never ends. We're learning more. We're doing a lot more testing, a lot more instrumentation. But with over 1 billion people using Facebook on mobile, this challenge just is getting harder and harder for us, right? There's no silver bullet. There's no easy answer here. And there's a lot for us to do. This is just one example of a type of challenge we face, and I know you guys all have similar challenges. Now, the other thing that I want to talk about here is our approach, because I think our approach to these challenges is pretty unique. We've come up with, all of us have come up with core principles and ways that we operate and ways that we've built and hired our engineering teams. And I think these are different, and they're different because most of the rest of the tech industry does not do things like this. Now, the first thing that I wanted to talk about here is just one basic thing, is that we focus on simplicity, we focus on building for flexibility, and we focus on building efficiently as well. We are all working on things that are big and complicated. There's a lot of interdependencies in the stuff that we actually build. We're all trying to push changes multiple times per week, hundreds, thousands of times per week and it seems to be increasing as well. So we're trying to really focus on building our services and our application in a simple, flexible, and efficient way so that we can stay ahead of this. And one example of this that I wanted to tell that happened at Facebook was back in February, March timeframe of this year, we launched this feature called Look Back Videos. And this was basically a kind of a personalized, customized video that we generated for your experience on Facebook. And we brought together, all of the different highlights and stuff that had happened to you through your time on Facebook and presented this as a custom thing that you got to see and reflect on. Well, I don't know about you guys, but Mark doesn't give us these grandiose, perfect, never-changing roadmaps that are 3 to 4 years out and gives us plenty of time to go build and design our infrastructure to support these types of features. Oftentimes we have months to build a pretty significant feature. In this case, we had only a couple of weeks to actually work on this feature. And we had to generate something like over 700 million videos in just the span of a couple of weeks. Each one is a custom video, and then being able to build, kind of piece together our infrastructure and our application in a way to make this available for people. So we pride ourselves on actually moving really fast here, and simplicity, efficiency, and flexibility in our services and the way we build stuff in this community is really paramount for all of us. Now, the second thing is that we all care about the full stack, and you're going to see that in today's talks. There's several talks today across data, mobile, and web, and all of us as engineers have to understand how to build stuff, how these things hook together, how to make them performant, how to debug things, and how to operate things, whether it be native code on a mobile device, a back-end service, a storage system, network, systems, hardware, and also the operations around this too. So all of this stuff is coming together, and you have to keep a lot of stuff in your brain these days. Now, there's a lot of talks this afternoon that kind of highlight this, needing to optimize and work on the entire full stack. So hopefully you'll get an appreciation of that today. Now, the last, almost the second to last one here is measurement. And as my colleague and friend Jeff Rothschild says, instrumenting stuff is basically the ROI is immediate and the payback is forever. We all love to instrument our stuff, right? It is something that's really, really important to us. It's how we learn how our stuff is performing. It's also how we make our products better, and it actually helps us iterate faster. We can make little changes, measure the effect of them, roll it back, tweak it, make the next change, and it really, really helps us kind of rapidly develop, and also, most importantly, is actually learn really, really fast. Now, it's also important that all of us really see analysis and data visualization. It also is a really important part of measurement. It helps us understand this very complicated data and these complex systems that we're building. And so there's a lot of work that goes into how we visualize, how we process this data. And in this room this afternoon, most of the speakers are going to be talking about large-scale challenges around data infrastructure. And the other thing that I think is important here is that most of us, we work in companies where data that we gather, whether it be business metrics, application metrics, or operational metrics, are shared with the entire team, right? They're not compartmentalized in some of the bigger companies. You have data that's compartmentalized and you can't share it, or I can't see your data. But we all work together, and we want to have this open culture within our teams where data can actually be used by everybody so that we can build better stuff and learn faster together as well. All right, so the last point that I wanted to bring up here is that it's about embracing failure. Now, there's a lot of motivational posters and paraphernalia on the web around embracing failure and trying harder and all that. But I believe that the companies that are represented here today really do actually walk the walk on embracing failure. And this is a core part of our engineering cultures. And we really do promote being able to take risks and knowing that some of these risks may fail and that there will be consequences. But we don't actually punish those. We don't actually squash those or put processes in place to prevent those types of bold moves that you all want to take when you're building stuff. Now, I think that this one is one that you have to be careful about, because it is not one where you want to be thinking or being reckless or for it to be an excuse around poor quality. We want to build our services such that we have proper bumper guards in place so that when a failure happens, the consequences of those are minimized to the users and the customers. And secondly, we want to make sure, per the earlier point, that things are measured, monitored, and so that we can respond quickly to a type of failure and be able to fix it, learn from it as well. Now, one of the examples that I think is pretty apropos for this is a Facebook project that we did a couple of months ago where we constantly work on how to make our services and the overall platform more robust. And what we decided to do a few months ago was turn off an entire data center region. Now, why? You may be asking, why would we want to do something this crazy? Now, this is not a small thing, right? This is tens of megawatts of power that basically we turned off of capacity for an entire day to test how our systems were going to actually respond. And we did a lot of planning up until that point, and we did several fire drills to make sure that we would be ready for the day. But it was really important that we actually pulled the plug the day of the event. There were several people internally that were like, yeah, this is all a charade. We're never going to actually turn the light off. We're just going to get ready, and then we're just going to dodge the final exercise. But no, we didn't. We actually pushed through that. We turned the entire region off. Now, the good news is that it was actually pretty boring for us, and that all of the prep work we had done for months before actually paid off. Now, there was, doing the actual test was really important for us because it really kind of surfaced out the unknown unknowns for us. And we were able to, find a bunch of things that didn't work and then put them back into a roadmap so that we could actually improve this. And we'll keep doing these types of drills to get better and better on the scalability of our system. But not being scared of that big type of failure was a really important part of this project. Okay, so listen, I can keep going on and on and on. There's lots of stuff here that we have, you all have, that talk about sort of the approach that we have to handling these types of challenges in our companies. Now, I think that these approaches that we have and these sort of principles that we work in, plus the challenges that I spoke about and the challenges you all face, make this community really, really unique. And it's also a key part of why I think we need to invest in building out this community in the coming years. Now, I want to shift to the last piece, which is hopefully the most obvious for everyone here, is that we're open. This community that we're trying to build is an open community. It's why we're all here. It's why we all talk. It's all why we share a number of things that we actually work on in a day-to-day fashion. Now, Mark built Facebook 10 years ago. He started off with PHP, MySQL, and then added Memcache a little bit later. This way, Mark was able to focus on connecting people and not actually having to spend his time on building out very basic infrastructure. We're able to grow today to 1.3 billion people, and Facebook's having to invest a lot of time and energy into building out our infrastructure, and a lot of it we are actually sharing back with the community as well. Now, there's a lot of power in the open source model, as we all know. It's a very valuable model for doing a lot of types of things in the world these days. It brings together hundreds, thousands of people across the industry, to solve specific problems together. And it's not just limited to your specific team that you've hired in your company. So you really get to broaden out and get expertise and information and code and solutions to the types of problems that you're facing today. And hopefully that enables you to go a lot faster. Now, this is not a new model, right? We've been doing open source for a really long time. So, the community is great when you are the consumers of the technology. The community gets to direct what the plan forward and the roadmap is going forward so that they can kind of weave it the way they want to in terms of how it solves their problems or your problems. Now, I wanted to talk a little bit about a new trend that I think we're seeing, which is because we're bringing a set of folks together that focus on at-scale challenges, we're seeing an opportunity here to sort of build a new type of collaboration around this sort of openness and around building this community. Now, I believe that only open is scalable, right? So only are we going to be able to build out this community when we focus on these types of scalability challenges that we're all facing and dealing with. And these are the companies that have, that are here today. Many of you have participated in some of these other at-scale conferences. And we've come a long way, but we still have a lot more to do in terms of building this, this community. And I'm really excited to actually see us all come together and figure out what we're going to do next here. So my favorite example recently is actually a project that launched back in March of this year called WebScale SQL. Now, WebScale SQL is actually run by these four companies. These four companies have come together to basically take their collective experience of running MySQL at large scale. So we have lots of war stories and sort of big scale deployment use cases to bring together and to actually take MySQL 5.6 and to start overlaying it and making it better with performance features, operational enhancement, bug fixes, and other types of enhancements so that we can run our version of MySQL and our large infrastructures better and better together. Now, one of the things that we're going to actually announce this week in a couple of days is this feature, Global Transaction ID. And this was a base feature in 5.6, but we found as we were running it at Facebook, trying to run it at Facebook, that there was several things that weren't kind of worked out with it to be able to run it at the type of scale that any of these companies on the screen would need to do. So we worked on bug fixes, we've worked on making it faster, we also worked on making it just more operationally sane to run, and that's going to be something that we put into WebScale SQL this week, and everybody will be able to benefit from this. Now, if I forgot to mention, WebScale SQL is also open. So if you're thinking about how to solve your MySQL challenges because you're facing some scalability challenges or problems, then I definitely encourage you to connect with this group and to check out the GitHub project so that maybe you can benefit from some of the work that's going into this project. Now, I wanted to just say one more thing here, which is based on the stuff that's happening here in WebScale SQL, we're going to announce a new project today. And the project is called the To-Do Project. It stands for Talk Openly and Develop Openly. And it's still very early on, but the idea here is that this set of folks are coming together and working on how to make open source better. We want to figure out how we can actually raise the bar in terms of the quality of types of open source projects there are in the world. We want to make it easier to consume open source. So if you're getting started and you want to consume or you need help or want to use something, we want to make it easier for you to consume. And if you're a company that is wanting to do open source work and to build a community or to contribute, but you don't know where to get started, the To-Do group is going to be the group that's going to help you. Now, we have still a lot to figure out here, and we just really got started only a couple of weeks ago in terms of pulling this team of people together. So if you're interested, the URL is at the bottom here, www.todogroup.org. So please sign up and help us out. We need a lot of help here. We've made a lot of progress in building this overall community, but I still feel like we got a long way to go. And with that, I think I'm done. So thank you all for coming, and I hope you guys have an awesome day.
Ladies and gentlemen, please welcome to the stage Cade Metz, Senior Editor, Wired Enterprise.
Good morning. About 3 years ago, I was brought into Wired to cover the sorts of things that Jay works on, these large-scale problems that people like Facebook were dealing with. And even then, people were questioning whether or not the rest of the world would care, whether or not these problems that Facebook faced would be faced by others. But it's clear now that it's faced by a tremendous number of people and companies. And that's one of the things we want to look at with four panelists who are part of the next wave of startups that are going to face the same sort of scale issues that Facebook has. So let me welcome to the stage Mike Krieger, who is one of the founders of Instagram, which is now owned by Facebook. Tuan Pham, who is the CTO of Uber. Selena Tabakawala, the CTO of SurveyMonkey. And Brett Taylor, the former CTO of Facebook, who is now the co-founder of Quip. We're going to look at not only technology decisions, but personnel decisions that the four of these CTOs make over the evolution of their companies. But we're also going to look, I think let's start with the technology and the stack that each of you have built. One of the cliches of the tech world is that startups use the cloud, but there comes a point where that may not make sense. And I thought we would start with discussing when it makes sense and when it doesn't, and how each of you specifically have treated the cloud versus building your own architecture. Mike, you recently, after building Instagram on Amazon AWS, brought it in-house to Facebook's data centers. So maybe you could just explain, A, why you did that, and how you'll continue to build on that infrastructure as we go forward.
Sure. So we kind of come full circle. When we launched, we had no idea what we were doing, so we were on one box in LA at like a leased sort of server facility, and within 12 hours it completely overwhelmed that single server, and we had like no scalability story beyond that. So we moved on AWS. This is back in 2010, and basically scaled up since then. And we got rescued by a few really key AWS releases. So we were totally out of Disk I/O, and then they came out with provisioned IOPS, and then we were again out of Disk I/O, and they had SSD instances, and so we were kind of kept pace with that and scaled with them. And then once we got down at Facebook, we were basically asked, like, hey, if it makes sense for you guys to move in here, we'll support you guys. If not, stay on AWS. Like, we don't want to slow you down. And over the last, it's been about a year and a half, we've migrated into Facebook. The biggest driver was actually integrating with a lot of the Facebook services internally. So we built a lot of sort of ad hoc ways of integrating into things like the spam fighting system, the huge like Hive and Hadoop clusters, a lot of the logging and analytics stuff that you'll probably hear about later today. So the biggest driver in this case was, it wasn't that something was particularly broken, it was that the more we wanted to integrate, the more it made sense to actually take that one time, like, it took a year, it was basically the whole infrastructure team's job that year, but it made sense in that situation for the integration purposes.
Right, you're in a somewhat unique situation because you're acquired by this enormous company. But Tuan, you guys aren't owned by Facebook, and some might be surprised that for the most part, at least for production systems, you use your own machines in your own data center as opposed to a cloud.
Yes, that is correct. Yeah, the Uber stack has always been running on its own managed data center. So before I came to Uber, I was at a company that builds software for infrastructure and power data centers and private cloud and stuff like that. So the theory goes, when you're small, it's really easy in your garage to basically spin up a bunch of machines on the cloud and get the business going, right? And that's really good. But I think at scale, it starts to get very, very expensive. So, but Uber is kind of unique that even way before I arrived at the company, the decision was made early on to basically run its own stack on its own sort of data center, right? Now, the company was really small at the time, and it didn't manage its own data center. Basically, it outsourced the management of those data center. And even then, it started to get pretty expensive at scale now for us. And also in cases, if the data center service provider isn't highly reliable, it can cause some pain point along the way, right? Yeah. When they have some interruption of services and all that. So we're actually in the process of cutting over, right, to doing our own. And when we plot the curve of the cost of operation of running either sort of leasing data centers and stuff like that and running our own, the initial cost is a little bit higher at smaller scale because you got a staff of a whole team to build out a stack and everything else. But at some point, the curve intersect. Right? And we are at the scale where those curves are about to intersect, so it actually makes much more sense for us to go on our own.
So, I mean, there may be cases where a company is willing to absorb those extra costs just because their traffic is going up and down, up and down. Yeah. But yours is, you pretty much know how quickly you're going to scale, right? And because it's pretty constant, it just makes sense to do.
Absolutely, yeah. The theories and the benefit of the cloud is the elasticity, right? So if you have huge bursts of demand that you can't really predict really well, and you don't want to always build out the capacity for maximum at peak load and then underutilize the rest of the time. That's not a really efficient use of resources. So that's when we use the cloud. But for us, our models, we have the number of cars and drivers on the road, and it's very easy to predict the growth of that, right? So when we have huge demand, actually, the dynamic pricing takes care of market equilibrium really, really quickly. So we don't have that kind of spikiness that you would need. You can take advantage of elasticity.
Got it. Now, Celine, your company is much older, founded in 1999, I believe. And so you came up, as the Amazon revolution happened, and how did you handle it?
Yeah, so we have a little bit interesting backstory, like you mentioned, in that the company was started in 1999, and so at that time, obviously, it was in its own data center, and the founder sold the majority of his share in 2009, so it was a 10-year-old company at that time, and already basically hosted on really a few servers with not that much infrastructure. And so when I walked in, we really had to make a decision around what we needed to do with both the app, that app that really needed a huge rewrite, as well as what to do with the on the hardware side. And similar to what Tuan was saying is we really don't have a lot of burstability in surveys. It's not like suddenly there's a rush to take a survey. And so when you thinking about from a cost perspective, we don't have that burstability, and so it did make financial sense to keep it. We did virtualize the whole infrastructure, which was a big difference. And then the other piece which we have is we have a lot of concerns around data security and privacy, and because we specifically do patient healthcare surveys, we have to be something called HIPAA compliant. And even then in Amazon, you need your own dedicated infrastructure. And so even again, then the cost goes up. So really, I mean, from a perspective of looking at your own business, it's always like for scaling, a perspective is really that cost model, and then what are your data concerns and data retention concerns.
And how about you, Brett? How have you handled things at that lowest level?
The startup that I started before it was acquired by Facebook, we leased space in a data center. At the time, Amazon's EC2 program had sort of just started, and it was sort of the features were too remedial to like run something that would be more trouble than it's worth to run it off of that. So I have kind of an apples to apples comparison. We're on AWS now at Quip. I think it would be almost crazy as a startup to lease space at a data center in this day and age, because it costs about twice as much. It's expensive to go on AWS, but the cost is nominal because your traffic is so low. And then there's a pretty clear threshold where you're going from finding product market fit to scaling your company, at which case at that point it makes a lot of sense to start doing cost benefit analysis. And I think right now, due to the cost, it's almost always much less expensive, as we're talking about with Uber, to lease space in a data center right now. That may change over time as the demand for large scale deployments on AWS changes, and certainly companies of Instagram scale and Dropbox scale get better pricing than most startups. But right now, I think it's not so much elasticity that I see, but just not having someone on your team work on that. And when you're 3 people in a garage, you just want that to not be an issue at all. That's not what you're building. That's not your differentiator. And so I think that transition point that Instagram face and others is actually the most interesting part of this cloud versus not cloud. I think it's unnecessarily awkward and expensive right now, and I don't think it should be, and I'm sort of interested in seeing in 2 or 3 years if the price point changes, because I think it's really inefficient that all these companies are really making that decision right now.
Got it. So given that, so what sort of technologies are you building at that level, down the bottom of the stack, to deal with this kind of thing? What kind of services are we building on AWS? Exactly.
Quip, one of our focuses is that it works on low bandwidth or non-existent network connections. So essentially, our entire architecture is based on synchronization, which I think is pretty typical of a lot of mobile architectures today. So like many companies, we sort of design our services around our API as opposed to designing around a web service like most people were designing before. And so we really think about our mobile client is essentially sort of a write-through cache to our servers. So we have our MySQL instances on AWS, which is sort of the source of truth, and then we have a SQLite database on our mobile phones, which is sort of the local source of truth. And everything is sort of like handled as a huge caching system that's distributed on phones. So it's really nice because we don't really do anything particularly exotic on AWS, but I think actually sort of the API-oriented approach is actually a nice sort of clean architecture that I think mobile development has kind of pushed a lot of developers to who would have done something more organic previously.
I see. So is there anything particularly exotic you're doing on SurveyMonkey, or anything else you can tell us about your stack?
Sure. As I had mentioned, we kind of faced this decision of having this 2 engineers working on a monolithic .NET stack, and this was in kind of January 2010, and we had to make a decision of both kind of what language did we want to choose, how quickly did we want to re-architect the application, and what pieces did we want to re-architect. And so, the main things that I was considering at the time was really how do you make sure that you're building technology to scale, not just technologically, but also for growing the team in the organization, because I knew we were going to grow far more than the 3 engineers we had. And so, we chose Python for our language and moved to a really similar service-oriented architecture where we had a services tier, because we knew one of the things that we wanted to do is we see, especially on the business productivity side, a lot of applications interoperating. It's created a public API layer so we can integrate with Quip, Evernote, MailChimp, still kind of different products people are using in the workplace. So that was kind of a pretty, that's the fundamental of our architecture is we have about 35 different services that small kind of teams work on and have an API layer that the public can connect to as well.
Got it. And does Uber have a similar services?
Yes, we have a distributed architecture. So we have also a service-oriented architecture. So we're actually pretty lax about letting every team run really fast and innovate on their own. So we actually have multiple stacks in the company, right? At the front end of it, you have sort of the mobile stack, right? Where you have sort of Androids and iOS platforms, right? And then you have the real-time infrastructure, which is one of the largest nodes installation that you have out there. Basically, that's make the market for us. Essentially, all the cars or the drivers matching with the riders and all that, right? And then we have sort of business infrastructure that's mostly on sort of Python, right? And then we have the core infrastructure that basically powers everything, and that's using open source, the technology that we have out there to basically, run the entire service. So, and all of these teams actually empowered to basically run on their own. They make their own architecture decision. The team kind of loosely coupled, but it's tightly aligned on the mission they need to do. And everybody just run flat out and do what they need to do.
I see. So how does your infrastructure compare to what they're doing in the services respect?
We had a very tiny infrastructure team for a very long time, so being service-oriented didn't make sense. It was like half a person would be running your service. Sense. But as we've gotten, basically the decision point has been when the current either stack or set of assumptions doesn't make sense. So when we did Instagram Direct, we needed it to be real-time, and like running a real-time app on top of Django with like a request response model makes no sense. So we built a separate real-time stack for that. Offline analytics is another case where you don't want long-running jobs. There's an async tier. But it's been very organic, to Brett's point. I think we started API first, but it's still has grown very organically from that and basically evolved from then. And we haven't undergone any kind of major rewrites. We've started on Django. Now we run kind of a modified Frankenstein version of Django that's evolved from 2010 to now, and of course it diverged enough that we could never really sync back to where it is publicly. But yeah, it's been mostly at the service of getting stuff done versus being too worried about rewriting it from top down.
Got it. And tell us about the various databases you use, because I know you use a wide range of databases for a wide range of tasks.
Yeah, and we've been actually trying to sort of funnel that in. Early on, it was sort of if this really solves this exact purpose really well, but what we've learned over time is then you end up with sort of one domain expert on that technology or two, and then if they're out of the office, then good luck. So we started going wide, but now we've really consolidated. We've used Postgres for almost all of our data storage, and it's worked really wonderfully. It's interesting being now at Facebook, and we've gotten to trade stories on what Postgres does well, what MySQL does well, and running both well at scale. Redis we used a ton early on, and it was kind of the Swiss Army knife that powered our team. A lot of the assumptions that it makes around keeping all your data in memory don't work great when you're dealing with a user base that not all of them are going to be active all at the same time, and you're paying that cost if all this stuff is in RAM. And then good old Memcache. That's one of the great things about being inside Facebook is getting to see like all the ways we were misusing Memcache and sort of a lot of the failover scenarios that Facebook has gotten really good at, and say, all right, this is what happens when half of your Memcache fleet dies, and here's how you recover from it, and here's the technology we've built around it.
Got it. And how about you at Uber? I mean, do you use a similar setup with?
Yeah, we the key word is evolution, right?
Yeah.
We're constantly evolving. We're constantly writing new stuff and rewriting old system because at the scale that we're doing. If you design something for 10x, it's only lasts you like 12 to 18 months, right? So you need to keep on constantly rewriting, and actually that's a good thing. There's a chance to actually retire some technical debt and all that. So in terms of database technology, we started out with MySQL. And then about a year and a half ago, right as I was arriving, the team switched over to Postgres, right? And then we've been seeing some sort of scalable scale problem with Postgres. So now we have sort of rewriting the entire new data architecture that is completely sharded, and actually we're going back to MySQL for data storage, right? And we keep Postgres for a portion of our work that depends on geo information. So, yeah, but the whole thing is like we're not afraid of bumping against walls and ceilings, and we just keep on having to reinvent our ways out of things.
Got it. How about tools for large-scale data analysis? I mean, that's got to be a huge issue for.
Yeah, we built our own data analytics, real-time analytics tools called Artemis, codename. At some point in the future, we intend to sort of open source that. But we also use some sort of data storage technology like Vertica and stuff like that. We license that technology to store the data.
I see. Okay. Yeah. And so, how do you use that specifically? The Vertica.
Well, we ingest a lot of data. Of course, we have all the data on trips and all of that stuff, right? We use that for demand prediction, supply positioning, all of those things. So there's really good use for that kind of data to make our service really great for people out there. When we're constantly trying to drive ETA down, and a lot of that depends on how we use data science, and on all the data we have.
Got it. And how about you, Selena? Data science, is that?
Yeah, so I mean, obviously our company motto is helping people make better decisions with data. So, but although we sometimes think of ourselves as a big data company, I really like to say we are lots of small data. So if you think about any individual user, they only have, on average, a few thousand responses. And so really what we're trying to do is give people great analytics tools from a consumer perspective. So a lot of that is in the web application framework. So a lot of JavaScript and kind of pulling the data really quickly in memory to essentially let users filter across tab the data and really understand that data and try to make sense of it. So it's not necessarily as much about and providing them what data sets are significant and statistically significant is kind of what we're working on as well in our analytics side.
Got it. So Brett, this was alluded to earlier, but we're now in a world where you've got to develop all these applications for multiple platforms. So how do you deal with that? Is there a particular setup that you use that allows you to manage iOS development and Android and other platforms, and how do you juggle those?
So yeah, when we started Quip, it was a handful of us, and we knew we wanted to develop for desktop, Android, and iOS at the same time. So we thought more about it since our product didn't exist yet, which was nice. So we designed it fairly intentionally. What we settled on is, as I mentioned, one of the main features that we wanted in our product is that it was sort of network connection independent, meaning if you went through the tunnel on the BART train, you could keep on working on your documents and you wouldn't have a hiccup, or if you went on the airplane, it would still work. And so that core synchronization technology was the thing we didn't want to have bugs. It's like, of all the things we were actually going to test, that was going to be it. So we wrote that in C++ because we knew it could be easily shared via JNI and Android and sort of natively in iOS. And we knew if we wrote that and tested it, it could sort of be the engine that ran our app. And then most of our Android and iOS apps are now just kind of the UI scaffolding on top of that. But our core editor and our core data synchronization is shared entirely between the two platforms. It's turned out, I think we had about 6 months of buyer's remorse during beta testing because it made everything a little bit slower at first. But since that, it's been about sort of a year since we launched when it was sort of stable. And every new feature we've done now works offline without additional effort. It more or less is trivial to make features that work across the two platforms. So I think I really am happy with the approach. It was really like a high upfront development cost, which was a startup. I still, question whether we should have done it later, earlier. But now that it exists, it's sort of the engine that drives all of our development. And we have a very, very small team of engineers, and we do all of our releases simultaneously on 3 platforms, which is something I'm really proud of. And I don't think we could have done it without an architecture like this. It's been really interesting talking to friends and colleagues at Facebook and Dropbox and others, and how a lot of companies I've seen have sort of converged on architectures like this, which is to sort of siphon off this core challenging functionality and try to write it, in a native way that can be shared. I think it's an approach I would do again, despite the qualms I had during the early days of QA-ing it.
Got it. So Mike, how about you? I mean, as you've grown from a small operation to a big one, how have you dealt with cross-platform?
So we were iOS only, which I think was the right call in 2010. Android was still kind of ramping up, and it was pretty hard to develop on. 2012 is when we finally launched Android. What was nice was the API was at least structured in a way that it was very, very little that we had to do. The only thing we really share are our OpenGL shaders, because those are kind of by nature cross-platform. Every time we get into sort of this, should we kind of break something off and have a core set of functionality, we try to make our apps as dumb as possible, and by that I mean we try to keep most of the logic not on the client side, so they're really just very good-looking viewers on a bunch of data. That changes a little bit in the graphics pipeline, and to the extent that we share stuff, it will probably be there, but then you start hitting trade-offs that you need to make between iOS, where you can read, the GL memory straight off back into your native code, and you can't do that on Android. Like, it ends up being enough differences that it makes more sense, I think, to run them independently. But it's a challenge. The other thing we find is, in the implementation, you end up making a lot of interesting assumptions that aren't necessarily in the product spec, as it were. Like, this is what happens on network failure, or this is what happens when people retry, or this is what happens when you double tap. And sharing that kind of implicit set of assumptions has actually been hard to, even on the UI side, to keep it consistent.
Got it. And so, Selena, I suppose from now until the end of time, we'll have talk of platforms that will allow us, to develop across all devices and systems, web, Android, Windows Phone. I mean, is there any hope for that in the near future, or not?
Well, so, I mean, when I look at it, I think that this is just trends that happen over time. So, I started eBite in 1998, and at that time you were developing, custom technology for Netscape versus IE to make everything look good and work. And then over time things evolved. There was web framework, CSS, that allowed you to essentially build much easier cross-browser. And I feel we'll get to that point as well. So, I mean, I don't think Apple and Google will ever really come together, but if, we think about it and say from a technology perspective, which is if your hardware improves, if the cellular connection improves, and the frameworks improve, can you essentially build more, whether it's native web, and include them in the apps, or how does that evolve over time? So I do feel like the development effort, how do you build more services so you're able to just put a UI layer on top? I mean, my view is that will continue to evolve, and you will have to constantly keep that change. So, my hope is, even though I don't think the end platforms will converge, I do believe that from a development perspective, we will be able to kind of reduce our development costs to develop across the platforms, which obviously, as you look globally, we have to.
Got it. So we spent a lot of time talking about technology, and we'll spend the rest of the day talking about particular technology decisions, but I think that one thing that's often lost is the people who run this technology. And how you organize them, who you hire. Tuan, how do you view that? As you scale, how do you scale your engineering team, which has to expand as your technology expands?
So first, you got to get as many talented people as you can get your hands on, right? Because with the scaling business, you need a lot of people to basically keep it moving forward. Now, the thing really interesting that we did was we sort of organized ourselves along the line, sort of vertical teams and horizontal teams, right? We have 17, 18 teams right now that basically just focus on their own mission of delivering feature and functionality in that segment of the market, right? You take sort of the Uber business concern and you divide them to these 17 and 18 of these slices. And you got cross-functional teams that actually run flat out and manage their own agenda, their own roadmap and vision and all that, right? And then we have 12 platform teams that basically worry about API scaling, all the core functionality that enable other platforms to move faster and enable all the programs to move faster. And once we divide ourselves into those 3 dozen teams or so, and everybody basically run flat out and and then execute really fast. So we're starting to see the effect of that very, very positively. A year ago or so ago, when we sort of growing from 40, 50 engineer to 100 engineer at a time, we start to feel ourselves really slowing down because we start tripping over ourselves a lot. And then when we got constantly re-engineer our process, every single sprint, every single quarter we get together and we say, well, what did we do well, what did not we do well? We figure out all the increasing friction as we get larger and larger. So then we kind of evolve into this structure, and now we hardly trip over ourselves anymore. So yeah. So when I get email from people outside the company, so how do you guys move so fast? How do you ship all those features in the last 5 or 6 weeks? It doesn't feel that fast to us inside the company. In fact, inside the company, we feel like we could do even more and move even faster. But you take a step back and take a breather, and you look at in the last 6, 7 weeks, we ship 6, 7 major features out there. They're all really large product offering. I think that's the result of us sort of untangling ourselves in terms of our process and our structure.
I see. And Selena, how do you view the human side of things?
Yeah, so I mean, I believe pretty similarly in the sense that we have pretty small teams, about 3 to 5 people, kind of teamed up with product and user experience design and automation testing, trying to build a part of the feature set. And giving them pretty large ownership in terms of you want your engineers to be able to innovate and be creative. And then I think balancing that for consistency and quality is what are the right guardrails to put in place, both from a business side. So I do feel very strongly in like quarterly roadmaps so we know what we're trying to do at a high level, as well as design patterns for UX consistency, and then a certain amount of what do you do on the engineering side to ensure there's API standards, or not accepting a pull request if it lowers unit test coverage. So what guardrails do you put in place but still allow that small team, that Tiger or feature team, to be able to have a lot of flexibility in terms of innovating on the product? And I think that that's really important for success and for people knowing why they're building what they're building and keeping motivated around that. Yeah. So I think that's pretty important.
So Brett, you've helped manage people at very large operations as well as smaller. So I mean, what is the difference with that smaller growing company, would you say?
There's huge differences because at some point with a large organization, once you get into the thousands, you start to deal with like problems of scale, which is you can't individually micro-optimize teams. You just have to create incentives and organizational structures from which those things emerge. I would say like one of the broader things that I've seen both at Facebook and at Quip though is, at least for mobile development, organizing around platforms, organizing around products. So in half the companies I talk to, they have an Android team and an iOS team, and then the other half will be organized around products or features, where there'll be sort of a team made up of an iOS engineer, an Android engineer, and a web engineer, maybe around a new product or feature. And I found that they have qualitatively different outcomes. I think the features tend to have a lot more consistency, and there's like a lot more camaraderie on the ones organized around products and features. But the downside of that is I think that the platforms are different enough now that there's a lot of idiosyncrasies and other things that like Android engineers collectively understand and want to talk about that is, you wouldn't have that same conversation in a team organized around a product or feature. I'm very much in the organized around the product or feature camp because I think that over time, like that's how you scale and that's how you move fast. And siphoning teams off by platform, it would sound like no one has like a Firefox team and an IE team now. That would be comical. But I think it will start to feel that way over time, even though right now it's, I think, sort of the par for the course for a lot of larger companies. And I think that there's a lot of trade-offs there, and I personally think that organizing the product but having, internal communication for the people who are have expertise in a platform is the right direction to go.
Got it. So Mike, your situation is different as well because you're no longer a self-contained organization. You're making all these decisions in large part in tandem with people at Facebook, right, who are running different parts of the infrastructure. So how do you deal with that? It's kind of a team that spans two organizations in a way, right?
It is, and I think you feel that more on the infra side than on the client side. The client side still feels really partitioned.
Yeah.
But then, there's just increased coordination. I think the thing that Jay mentioned around, turning off an entire data center, it's like, well, we have to deal with that. And like Amazon wouldn't do that intentionally, right? So then there's the different side of that. We dealt with that. But the client teams, it's really interesting, Brett. I think we're in that state where, what do you do when you have 2 Android engineers? You hire 2 more, right? Now you have an Android team of 4. Now we have client teams of about 15 each, and we're starting to feel some of that, like, well, there should be a product, like these folks focusing on growth. I'll speak to the other side, which is the one thing that having that very verticalized team, or horizontal, depending on which way you structure or orient yourself, but very platform-specific team, is the quality on each of those. The quality ends up being really solid, and like one of the things I'm struggling with as I think about how to evolve the org is, we focused a bunch in the first half of the year on Android quality, and Tyler's speaking about it later today. And we got our cold start time, so time after you tap the icon and get actually functionally working app to the lowest we can measure across any major app. That's really hard to do when you're product oriented. It's like, well, yeah, we slowed down our cold start by like half a second, but it's really worth it. And all of a sudden you have 8 teams doing that, and you're in the situation where it gets slower and slower. So that's a difficult trade-off, and I think getting those roadblocks in place is a lot harder on mobile. But we have things like one of our engineers put a test hook in there after everybody commits, and if it lowers cold start time, it won't accept your diff. So you can try to systematize those things as well.
And this is a classic issue at Facebook where you have so many people contributing to the code base that it's sort of the tragedy of the commons. With the JavaScript bloat, the CSS bloat, the startup time on mobile, and there's a bunch of things you get. And I think that's sort of the fundamental challenge of scaling an engineering team is optimizing for relatively autonomous independent teams while reducing the risk of having all those teams contribute to the same product. But I do think at the end of the day, that's the problem that you should solve, as opposed to having things continue to be monolithic. Not you now, I just mean over time. It just seems inevitable to me.
Got it. Well, thank you all for coming. Do appreciate it.
All right, so just a couple of notes on some housekeeping stuff. So we're about to get out of here, and so the data track is going to be in this room. If you're interested in hanging out and checking out the data stuff, stay here. Food is on the 4th floor, so 1 floor up, and there's also plenty of space up there because we got a lot of people today. If you just need to hang out, talk to people, congregate on the 4th floor, and then the web and the mobile track are up on the 5th floor today. So have a great day. I encourage you to stay off of your work email and phone and all that, and actually spend some time actually learning, geeking out. This should be really, really valuable. Meet some new people today as well, and we'll see you later. Thanks.